Hi, my name is Connor Herndon. I'm from the Society of Physics Students at the Georgia Institute of Technology, and I'm here to talk to you about groups. If you're watching this video, I'm going to assume that you're either a physics major or you're interested in physics or something like that. So, groups, even though you may have not heard of them, you will most definitely recognize immediately their structure, and hopefully understand the implications of a mathematical entity such as groups. So this is just going to be a very brief introduction. I'm probably going to have some follow-up videos explaining how to use them, maybe just some more concepts and delve deeper into group theory. But I think it's good for you to at least see it, because a big problem that I see in physics, and I love it, I love reading about this in history, is like physicists will come upon some physical problem and they'll try to solve it, and they have to develop some new mathematical technique to get through it. And only at the end do they realize that this was done by the mathematicians hundreds of years ago, and they just never actually read up on the mathematical work. So before that happens to you, you should probably at least look into group theory and see what sort of discoveries have been made, because I believe that a physics degree is nothing more than sneakily teaching kids group theory without telling them what it is. So it's extremely useful, especially in problems of symmetries within your dynamics. My explanation of group theory is going to be extremely physics level, very in some ways qualitative, so if you have any problems with my rigor in this, deal with it, or you can email me or leave a comment or scream angrily at me. That's totally fine. I just want to give you a general understanding of what they actually are. So to start you out with groups, you need two basic, very general things. First is you need a non-empty set. So a set of elements is, hopefully you know this, it's just a set of elements. You have a collection of items, a collection of entities or concepts, just things, mathematical things. And you also need a product between these. So basically you need some form of concept of how to combine two of these things. It's a binary operation. Two of these elements in your set and return something else. So there's a few more restrictions on this product, and those restrictions are what make it a group. So the first of these properties that's really easy just to grasp is something called closure. So that means, let's say we have this bag of elements. This is our set right here. We got these different colors in here. And we have some product that can put both these two elements into another. When you product the green and the blue element, you get something else. So closure just means that when these two come together, you have to get something else that was in this original set. You have to reproduce something that was in the original set. So let's say red. You can't produce something like yellow, because that would just mean that whenever you put green and blue together, you get something that's not even in the set, that's not closed anymore. Next up is associativity. You probably know what this is, but just in case you need some help, if you have three elements, let's say this there's blue, red, and green, even though the order matters, that you can't switch these two elements, the order that you multiply them together does not matter. So let's say you could multiply both of these together first, produce an element, and then multiply this element with the green. Or you could move the parentheses and multiply the red and the green together first, and then that product with the blue. Next one up is the existence of an identity element. So there must exist some element within your set such that any other element multiplied by it does nothing to it. It doesn't care. So that would be, for this ghost-looking element, if you multiply it with blue, it just returns blue again. So you have to have some element like that. And the final property is the existence of inverses for every single element in your group. So what this means is that if we have the red element in our group, there must exist some other element, this will be just the faded outline of red, such that when you multiply them two together, you get the identity element. And there must exist one of these inverses for every single element in your group, so there must be one for the blue as well. So that's just a very super general overview of what a group is. I want to create some more videos later on for group theory and things you can do with it, especially in physics using symmetries. So if you have any suggestions, please make a comment or email me. Again, anger is always accepted as well. But if you want more rigor, go to the math people. I'm just here to give you a good idea on the physics perspective of these mathematical entities.